Hello everyone, I'm Snigdha Kakkar. This is my channel AccelerateAICareers. Today, I'm going to discuss a very important LeetCode problem, LeetCode 221 Maximal Square, which is really famous these days within the FAANG and other companies for their coding interview rounds. So let's look at which companies are asking these questions. So Google, Amazon, Meta, Apple, Booking.com, Adobe, Oracle have asked this question in their last 3 to 6 months of interviews. So let's see what does this question say. So basically, as you can see from example 1 here, you have been given an m by n cross binary matrix. Binary matrix means that the matrix is just filled with zeros and ones. You have to find the size of the largest square containing only ones, no zeros, and you have to return its area. So basically, it cannot be a rectangle, it needs to be a square, and it just can have only ones. So that's your entire question. It's a medium level complexity question given here. But once you understand the intuition behind it, you would consider it as an easy level question. It's not a tough question per se. So let's take our own example and see how we can solve this question. Here I have a 3 by 4 matrix just filled with binary numbers, zeros and ones. So now how will you go about solving this question intuitively? Like, if say suppose you are given this question as a novice, what would be a brute force approach here? So I would say if I would have been given this question before I knew coding, my approach would be that I would start with I equal to 0, j equal to 0 here in the matrix. And then I would check whether this value is at least 1 or not. If this value is at least 1, then I'm sure that a square of area 1 is possible from this place. Then I'll go ahead and check if its neighbors are 1 or not. So basically, I will check if the value next in the cell is 1, which is not here, it's 0. If the value bottom cell just below this cell is 1, which is yes, it's 1. And if the value in the diagonal cell is 1, which is 1. But I would check if all threes are ones. If all these three neighbors are ones, then I would be sure that at least a square of area 4, that is 2 by 2 size, is possible filled with just ones, which is not in this case. Now, so I don't need to check for a square of size 3 by 3 then. And then I would move to the next cell and then take it as the top left cell of my desired square and check if the value in it is 1, which it is not. So there is no square, even a square of area 1, not possible from here. Then I move to the next cell. And in the next cell, I will check if the value is 1, which is 1. Then I will check for its neighbors. And when I check for neighbors, I see that one of its neighbors is 0. So a square of only area 1 is possible from this place. Then I go ahead and I check for the next one. And I'll keep on doing this for every row and for every column, which will help me to find that square, which will be of the largest area. And I'll keep on updating area every time for the max square found. And I will return the max area found at the very end. That would be my brute force approach. So basically, I will be using nested for loops here to solve this question. If I am a novice and if I have not seen this question before, I don't know any of the coding algorithms. So in that scenario, my time complexity would be O of m into n square, because I'm essentially running this nested for loop so many times when I'm checking for the neighbors as well. So now you will ask me, this is too much because the square could be this m and n size could be a lot. And then m into n and then its square, it's too much. So is there a way to reduce this time complexity? So the answer is yes. And the way I'm going to do is I'm going to use cache. I'm going to find a way to break this entire process, which I just described in my brute force approach, and to make it more repeatable, to find more structured repeatable steps such that I can use my cache to answer that. Suppose I'm here at top left value here 1, and I have to check for the 3 neighbors and the value in this cell itself. So first I check the value in this cell. That is a step which is non-negotiable. You have to check that. And then I will check for the neighbors. And every time I check for the neighbors, I will not just check for the value in the neighbors. What I will do, I will check for how much maximum size square is possible from each of its neighbors. So basically, my cache will store the position, that is r, c, row, column. That would be the key, and the value would be the largest length of the square possible. So say suppose this is the value which I'm starting with, and then I'm going top down, and this is memoization because I'm using cache, and I'll be checking its neighbors, and every neighbor's cache will have the maximum length of the square possible, which will have only once. So say suppose I check for this neighbor, and this neighbor essentially I'll have to check for this neighbor, and this neighbor, right? Now, if I have to answer for this maximum square length possible, I will have to check for this neighbor, and this neighbor again. So now, if I have to check for this neighbor, I'll have to check for the below cell, which is not there. So essentially, anything below, there is 0 squares possible. Anything diagonal, there is 0 squares possible for this cell. And if you look at the right, for this cell, you will again see for this cell, anything below 0, anything diagonal 0, anything to the right, 1 cell, right? So again, for this cell, you will check below 0, diagonal 0, and on the right, only 1 cell. So square not possible. If you look at this bottommost cell here, it doesn't have a below neighbor, it doesn't have a diagonal neighbor, it doesn't have a right neighbor. So essentially only square of size 1, length 1 is possible here. So I'm going to update my cache accordingly. So let me show you that. Here I've taken a cache also of size m cross n, and you can see that I have filled it out with the length of maximum sized square possible. So just the side length. So basically, how did I compute it? For this particular cell, if you see, for this cell, any cell neighbor below it is 0. Any neighbor diagonal to it is 0. Any neighbor to the right of it is also 0. So the square having 1 possible from starting from this cell is possible only of side length 1, hence 1 here. Now let's go to a cell just above it. For this cell, its bottom neighbor is this, which has maximum length of square possible is only 1. Its right neighbor is 0, and its diagonal neighbor is also 0. So essentially, for this cell, maximum size square possible will only be 1. Because if you take these two cells, it doesn't form a square, it forms a rectangle. So hence 1 here. Similarly, on the cell just above it, its bottom neighbor has maximum square sized possible 1, but it has a right neighbor with 0, and it has a diagonal neighbor with 0. So min of these is 0. Hence, a maximum length square which is possible out of this cell, starting from this cell, will be 1 of side length 1. That's how you got the rightmost column. Now let's move to the neighboring column. Here, this cell. So for this cell, the cell below is 0, diagonal is 0, the right is 1. So minimum of all these 3 is 0. Hence, the maximum size length square possible here is 1 because this cell at least has 1. So 1 plus min of all of its neighbors. So 1 is the answer here. Now let's go a cell above it. This cell itself has 0. So you cannot have a square which just have 1 starting with a cell which has 0. Hence, number of square or maximum length square possible from this is 0. Hence 0 here. Now let's go a cell above it. Now this cell has 1. So at least a 1-sized 1 length square is possible from here. Now let's check its neighbors. So one of its neighbors has 0 here. And hence it has 0 length square here. So minimum of these 3 plus 1, which is 1. So hence a square of length 1 is the maximum square possible starting from this cell. Similarly, let's fill out for this cell. Now for this cell, it doesn't have a below neighbor, it doesn't have a diagonal neighbor, it just have a right neighbor. So for the right neighbor, maximum length square possible is 1. So the minimum of 1 and 0 is 0. So the maximum length square possible is 1 here. Similarly, if you go to a cell just above it, 1, then this one will have 3 neighbors, right? It has 1 in the bottom, 1 in the diagonal, and 1 in the right, right? So 3 neighbors. But one of its neighbors has 0 here. So it is limited by that. It cannot have a square of size length 2 because it has neighbor as 0 there. So the maximum square possible is 1 here. And the formula which I used was minimum of all its neighbors here, which is 0, and plus 1 because there is 1 in this cell. Now let's look at cell above it. This cell itself has 0, so there is no possibility to have a square of all 1s here because this cell itself has 0s. So the value here is 0. Now let's look at this cell. Now this cell doesn't have a below neighbor, it doesn't have a diagonal neighbor, it just has a right neighbor. And that right neighbor has maximum length as 1 for the square possible with only ones. So minimum of these 3 neighbors is 0 plus 1 is 1. Now let's look at this cell. Now this cell has 3 neighbors, and each of its neighbors we will check how much maximum length square is possible. So maximum length square possible is 1 in each of these 3 neighbors. So minimum of all these 3's would be 1, and there is 1 in this cell itself. So 1 plus 1, that is maximum length square possible from here is 2. So, and then similarly, you go to the top left cell, and from there you see all its neighbors. One of its neighbors has 0. So minimum of all these 3 neighbors would be 0. And then 0 plus 1 is 1. So your square, maximum length square will be possible only from this cell, that is first row and first column. So first row and 0th column. So this is the cell, and the maximum length of the square will be achieved from the cache. And once you achieve the length, you can return the square of it as the answer, because you have to return the area of the square possible. So the answer would be 4 here. So this is your entire notion behind solving this question. It appears to be a lot of work, but it is a small formula. We are using memoization, so you don't have to compute everything again and again. We'll be using a nested helper function to do that, and we'll be storing everything in the cache. So when I code it, you'll be able to understand it better. I would suggest that since you have understood the notion, pause the video now and try to code it yourself. And let's proceed towards the coding side. Maybe your doubts get resolved there. I'm solving it using cache and top-down memoization. You can also do it using dynamic programming, bottoms-up approach. You just have to change a few lines of code. Basically, instead of starting from top down, you will start from bottom up. You will have to shape the helper function also a bit instead of using cache. So let's proceed towards coding. First of all, I'll create 2 variables, rows and columns. And rows would be length of the matrix, which is this. And columns would be length of the first row of matrix or any row. So this is your rows and columns. Now I'll initialize my cache. I will take a hash map as the cache, where my key would be the rows and columns, that is R, C. And I will be mapping each R, C to the value which is the length of the maximum square possible of ones possible. So now, after I have initialized the variables, I want to tell you that the time complexity for this solution which I am proposing, or dynamic programming bottom-up approach, both of them will have time complexity of O of m dot n, m into n, and the space complexity would also be O of m into n, because I'm using cache here, okay? And I'm using hash map as a cache there, okay? So now I will define my helper function, and my helper function will have 2 things passed, row and column R, C. After that, I will first check for my base condition, and my base condition would be if it is out of bounds. So if R is greater than equal to rows, or C is greater than equal to columns, in such a scenario, you have to return 0, because there is no length of square possible there, right? There will not be any ones there because it's out of bounds. After that, once you have checked for the base condition, which would be similar to like in the bottommost cell here. So now I will check if this R, C is not in cache, because if it is there in cache, I can fetch the value from the cache and return. And that would be my return here. So I'll write return cache R, C if it is in the cache. Now, if it is not there in the cache, then what? So then I have to check for 3 neighbors. Suppose for this cell, I have to check for 3 neighbors. One is cell just below it, one is cell just diagonal to it, and one is cell just to the right of it. So that's what I'm going to do. Down helper. I'm going to recursively call this function. And how do I get the cell just below it? By increasing the row count by 1 and keeping the column as same. Now I'll get right as keeping the row as same but increasing the column count by 1. And then diagonal. For diagonal, I will increase both. I'll increase row also by 1 and I'll increase column also by 1. So now I have calculated these, I will save these values in cache. So my cache for R comma C, I will initialize by 0, because right now I don't know if how much maximum length of square is possible there. And this value is not in cache yet. So I will update this value cache R comma C, initialize this value by 0 at least. And then if the value in this current cell R comma C, this cell is 1 itself, as well as the neighbors have ones, then I will calculate the square accordingly. So now if you see, this matrix does not have integers, it has values 1 comma 0 in string format. So I will have to check if matrix R C, this value is 1. This is my first check. If this value is 1, then I will update my cache, because if this value is 0, cache RC would still remain 0, because there is no possibility to have a square with just ones there if the cell itself has 0. So cache RC will have 1, because the cell has 1, so at least a square of size length 1 is possible. 1 plus minimum of these 3 neighbors, down, right, and diagonal. So this will be the length of maximum size square possible. So 1 plus minimum of all the 3 neighbors. And then your cache will be returned. So if your neighbors are all 1 and you also have a cell 1 there, in this scenario 1 plus minimum of these would be 1, 1 plus 1, 2. And hence that 2 is returned. But if your current cell has 0, in that scenario 0 will be returned. If you understand the concept, it's pretty clear. It's pretty easy. And then I just have to call this helper function. So I'll call helper. And since I'm going top down, I'll call it at 0th row and 0th column. So helper 0, comma 0. And finally, what I need to return, I don't need to return the maximum length squares side length. I have to return its area. So I will return max. Whatever cache I have, it's a hash map, right? So I have to get cache.value so that I get all the values, and whatever the maximum value is, I have to return its square, because I have to return the area, and area of square is side square, right? So that's my entire code. As I suggested, time complexity of mn, space complexity is also of mn, because I'm using a hash map here. Let's run the code and see if it works. So there is a runtime error and says dict object is not callable. There is an error in line 21. Let's see. Okay. So I think I understand where I made a mistake. I have to put cache R comma C. And yeah, so this solution is accepted. Let's submit. As you can see, the solution is doing quite well here. So this is the entire code. If you have any other better approach, also do mention in the comments. If you like my way of solving problems, subscribe to my channel to get notifications for your daily LeetCode challenge. I'll keep you posted. I post one video every day. Thank you.